In this video, we are going to see how to test a distance protection relay using the internal XRIO module. So you have the option here, the advanced menu. When I click on this, you have the impedance screen. Under impedance, you have two options. One is the manual impedance screen, where you can enter the values and test directly without reproducing the entire relay settings, and the other is the automated module, where the full-fledged library is available. So let us see the library module. In the library module, you have the option to import the RIO file and also the library. So let me click on the library. You have the list of relays available here. My test kit is currently connected to ABB make REL 670 relay. I will select REL 670 from this list, and this is the place where I enter the values as per the relay. Alternatively, I can also import the XRIO file, which I have saved in my desktop as rel670.xrio. When I open this, it has successfully imported all the settings. So let me put a tick mark. You have two menu screens here. This is menu A and this is another menu B. So when I click on this menu A, it goes back to the previous menu where I can modify the values or import the XRIO file. If I click on this menu B, this is for test screen menu. So when I click on this, it provides the following options: pre-fault, control, ramp or short, CT or PT ratios, and the timers that is configured as per the XRIO. So the REL 670 relay has 5 zones, in which 4th zone is disabled in this settings in this relay. 1, 2, 3 is configured for forward, and the reverse is configured as zone 5. Pre-fault, I have defined it for 2 seconds with 60 volt, constant current, limiting the current to 5 amps. Pre-fault and post-fault, you can enter some value that you want. Ramp or short. So you have 3 options here. The first one is a random short test, where you can click on any location of this impedance menu and create a fault. The second option is a linear search option, where it searches from outside and it moves towards the zone in a linear fashion and tries to identify the exact point where the relay operates. In this way, it provides the exact point where the zones are created, the zone boundary to be more specific. So since the point is moving from outside to inside in a linear fashion, this test we call it as linear search. The other option is pulse binary search, in which one point is configured outside the zone and the other point is configured inside the zone. So let us say your impedance boundary is at 10 ohms. So first I give a fault at 20 ohms and ensure that the relay is not tripping. Then I give a fault at maybe 2 ohms and ensure that the relay is tripping. So if this is true, then I come near the boundary. Again I repeat the process with 15 ohms, it should not trip. Then 8 ohms, it should trip. Then again come closer. So in this way I give pulse binary values and identify the zone. So this is the way by which these two ramping tests are configured. So let me first play the short test. We also have this polar or rectangular plot option. So let me keep it as polar so that I can view my impedance and angle. Let me clear all the results and remove all the fault types. So I have the zones as per my relay: zone 1, zone 2, zone 3 and zone 4. The type of fault I can select from here: single phase to ground, phase to phase, 3 phase. So let me select the A phase to B phase fault. So since I am in a short test, I can click anywhere. So let me click here randomly. So the moment I click, I get the impedance, magnitude and angle, which can further be edited and fine-tuned in case required. So let me go to the relay. In the relay I have configured second LED for zone 1, third for zone 2, fourth for zone 3, and fifth for zone 4, and sixth for zone 5. So zone 4 is disabled, we have the reverse zone as zone 5. So let me run this test. To run this test, just click this play button. You can see that the relay has flipped zone 1, and you also get the fault location here, 167.85 kilometer, which is 63%. And in the software you can see it's green in color. Since I have connected the feedback to the test kit, it's successful. Now let's go to the second zone, another point. Let me reset the LEDs. Okay, I'm going to play this fault. This is a zone 2 fault, so the relay has operated in zone 2. So let me do a zone 3 fault. Let me reset the relay. Zone 3 and another in zone 4. Let me reset the relay. So this is how we do this testing. You can select as many points as you want in each zone in wherever location you want, and just run this double play arrow mark. Everything will be run in sequence and you get the results here. The results are saved in this location. So by clicking here you can get the complete results available. And one advantage of this results window is you can play back the fault again from the report. So when I import or save this report, you can open in another laptop where the software is installed, and you can import and just click on this tick mark. It goes back to the previous menu and imports from the test results. So 4 or 5 relays with similar settings, you need not create the test plan again and again. You can just run the relay 1 results on relay 2, 3 and 4. It goes on. So this is the simplest way to do using Xrio. Now we are going to see how to test phase to ground, 3-phase fault and phase to phase fault. So in an automated fashion, let me click on AB and let me select random points in each zone. Then I am going to select A phase to ground, and I am selecting points in each zone, repeating the same process for 3-phase. So what I am going to do is I am going to click on this double play button, which is a automated test screen for playing everything. So what are the phases where you want to play, that you can select here. So let me select AB, A phase and ABC for all the zones, short test. So when I click play button, it's going to run everything in sequence. So let's see how it works. Now we are going to see a ABC fault. It's injecting a ABC fault in zone 1, so known as operated. Now it's zone 2, ABC fault in zone 3, reverse zone. Now it has moved to AB. So the green indicates that the feedback is in accordance to the time and the test case is passed. So now it's performing a single phase testing, A phase to ground, for all the three forward zones and now in the reverse zone. So that's it. It's a simple test, and you can see the results here by clicking on this tab. So page 1, 2, 3, 4, 5. So let me click on 4. So you get this ABC points with the test results, RX value, timing, AB, and A phase. In short test, we are going to see one more option for choosing the number of points. So we saw the random clicking of points like this in each zone. Let me delete the fault types. So you also have an option, a shortcut menu. So by pressing here, it automatically selects the points. So it's a quick way to do the testing. Now let us see the results section, how to play the file back from the results. For that I am going to do a short test with 2 points, which is already tested. So let me run the test again. One in zone 1, and another point in zone 2. I have done both the tests for R phase to ground, A phase to ground here. So now when I go to the results menu, saving impedance report, and I get the report here. Now from here you can see I can select any phase. So we have already done the result in A phase. If you want to repeat the same for B phase or for C phase, just select here and click the play button, execute all in group C. So this means whether you want to do all the list of tests, in case if you have 10 tests, it will just execute for all the C phase. So that option you can directly do from the result screen. So now let us see the ramp test, the linear ramp method. Let me select the linear ramp, and I am going to do the boundary search using linear ramp for one forward zone and one reverse zone. So here there is a button called a magnifying button, so I can zoom which zone I want. So let me zoom the forward zone. This is the biggest zone. I am going to click on one point and another point. So the rule is you click one point outside the zone and one point inside the zone. So what the test does is it starts injecting a fault from this point, outer point, and slowly moves towards the inner point linearly, and the moment it touches the line it should operate. So it searches for the boundary in the location where you have clicked. So let me zoom for zone 5, the small one in the back. So I am going to click one point outside and one point inside. So the more close it's better, otherwise the test is going to take a lot of time. After doing this, the points that I have entered is here. Forward is zone 3, reverse is zone 5. So let me run zone 3, outer zone. So you can see it starts injecting from the outer part of the zone to the inner part of the zone in A phase to ground, which is selected here. So the relays LEDs are in reset condition, and the kit is slowly moving towards the zone. The moment it enters or touches the boundary, let's see how the relay operates. It's still moving. Yeah, the relay has operated. It's in zone 3. The relay has stepped in zone 3 and the operation point is in green color. And this is the reverse zone. Let me play the reverse zone now. It's running from the outer boundary to the inner boundary. I will just reset the relay. Yes. slowly moving towards the zone. It should operate anytime. Here you go, relay is operated. So this is the way by which the linear ramping method works. Now let us see the pulse binary search method, the third type of testing in this module. The same 2 points, one for zone 3 and the other for the reverse zone. So let's see how fast it is going to work. The concept is one in the outer dot and the one in the inner dot. So in the outer dot it should not operate, and in the inner dot it should operate. So the test is continued till you get 2 continuous strips from which the exact boundary is identified. So you can see how fast it is able to identify the boundary. Let me do it again for the reverse zone. So compared to the earlier test, the linear search method, the pulse binary search is a very fast way of identifying the zone. It has identified. So you can click as many points as you want in various locations in each zone and repeat this step. By clicking on this double play button, you will be able to perform everything in a single shot and you will be getting the results in a single screen. Let us see the other test options for the search test. So this is the linear search and pulse binary search which we already saw. So now we are going to see the shortcut for the testing methodology. Earlier we saw that we randomly clicked on the points, one outside and one inside the zone, and it was able to do the test. Let me clear the fault types. You have 3 options here. One is on IEC 60255, the other is something with 5 lines display, and the third is 3-line display. Let's see one by one. When I make it as IEC 60255 and when I click on this point, automatically you have 3 points in each zone assigned, and it will be perpendicular to the x-axis as per the IEC 60255 standard. So let me delete this type and see the next one. This is a display with the 5 lines in it. So let me click on this and see what it is. So it's going to draw 3 points in each zone, but it is not perpendicular to the x-axis. One will be parallel, one will be parallel to the y-axis, and the other will be at the line angle, and one will be in the reverse zone, and one will be 180 degree out of phase to the x-axis value. So this module will test these points. So let me delete and see the third type, which has 3 lines in it at the boundaries. So when I click on this, you can see the only difference between the previous one and this one is it doesn't extend up to the origin, but here also you get zone 1 3 points, so 3 points in each zone. So this would be a bit faster than the earlier one, since it is not extending till the origin. So when you run the test, automatically it executes all these points and you get the results.